Hello, it's Dr. Liu. So this is second video talking about development of a robot simulator supporting OPC UA using Python, VTK, and wxPython. And this is the first step to prepare Python, VTK, and wxPython development environment. In previous video, I talked about the development environment selection. We have many choices. Eventually, we selected Python as a programming language, VTK for the robot model visualization, and use wxPython for the software GUI development. Use the free OPC UA package for to support OPC UA communication, and using threading module to support multi-thread. So in the following slides, I'm going to explain how to set up the Python, install the Python and the Python IDE, and explain the usage of VTK, wxPython, OPC UA package, as well as threading one by one. In this development, we use Python 3.9, which is a stable version of Python released on October 5th, 2020. Please download the 64-bit installer for Windows from the python.org website. And then you can select which IDE to use for your development. One choice is Visual Studio. Another choice is PyCharm. So if you're using the Visual Studio, you need to install the Python support for Visual Studio. So I used the Visual Studio first, and then later I tried the PyCharm. So PyCharm has community version, can be downloaded from JetBrains.com website. It's a very user-friendly Python IDE. So in the following explanation, I will focus on using the PyCharm. So in most of the time, you will need to use pipe, a Python package index to search and install necessary Python package developed and shared by Python community. In Visual Studio IDE environment, on the pipe, search necessary packages to install, or sometimes you need to use some pipe command in Windows command share to install. In the PyCharm environment, we can search and install all the necessary packages under the Python packages tab. So below list showing all the required Python packages. First one is VTK, the latest version is now 9.1.0, and then wxPython, LXML, OPC UA, those are easy to understand. PyMessageBox, which is a simple cross-platform JavaScript-like message box module. We can use it to display the messages quickly during the program debugging stage. PyPubSub, is to send and receive messages between threads. PyInstaller is a module to bundle the Python application with all dependencies into a single package. You can deploy the package to other place and then run it without Python interpreter environment or other modules. Py2exe is a distribution utility tools which allow us to build the developed Python application as a Windows executable program. So it's a very useful tools. First, let's download the Python latest Python from the python.org website. The latest Python package installer is 3.10.1. You can download from here directly, or you can go to here looking for specific release. In my case, I'm using 3.9.0. Yeah, this one, released on October 5th, 2020. So download and install it, and also set up the environment according to the setup procedure. So there's a lot of video on the YouTube talking about how to install the Python environment. You can refer to that. So after the Python environment is set up, next go to the jetbrains.com, download the Python IDE PyCharm. Well, unless you are using Visual Studio, you can skip this process. So you can download basically there's two versions available. One is professional, another one is a community version. So community version is free. You can download from here. After download, you can run the installation. After installation, you will have you can run the PyCharm, and the GUI will be looks like this. So the left area will display the project, and you can create the new project and drop all the project files into that project. So in my case, I create a project called VTK Robot Simulator, and I put all the Python files and other document into that folder. So assuming PyCharm project is our default folder, under here we have VTK Robot Simulator folder, all the Python program, robot specification data, even the robot STM model I saved in this under this project folder, which can be accessed from here. Then the bottom will have several important tabs. One is called a Python console. From there you can run some Python command directly, or even run the Python program. Another one is called a Python package, where we will use it to install all the necessary Python packages. And here will be display the program, or even some files that in your project folder. So under the Python package, we need to install all the necessary modules that are packages that we mentioned. First one is VTK. So in my environment, everything has been installed, so we can see the VTK. I have installed the 9.1.0, this latest version. wxPython, this is something you need to install. If you don't have it, you can just input the name. If just give an example, if I try to install something else, for example this one, I love installed, you can just click install on the right side, it will be installed. So in my case, VTK, wxPython, all the module I have installed. So you need to, I can show you that wxPython VTK PyPubSub for the message, sending message between thread, PyMessageBox, PyInstaller, Py2exe, and also OPC UA. And the last one is LXML. So those are the OPC UA, Python packages that you need to install. So after you've done that, pretty much you will have the correct Python environment, which is 3.9.0 ready, and you have the Python development IDE, which is a PyCharm, and you set up the project file and the project folders, and you installed all the necessary package for this development, then we're ready to go. After set up the development environment, we need to verify each Python module and the package works. So the first one is VTK. That is for robot model display, manipulation, and process visualization. To visualize any data in VTK, it usually requires to set up a pipeline like this. And the VTK provides all the necessary classes to construct or load the source and implement this pipeline. The first step usually is to construct object or read the image or models from STL file directly. Then the filter is going to take the data, raw data as input, modify it in some way and output it. The mapper is going to map the data to geometry primitives like points, line, and triangles to be displayed by the renderer later. And the actor represent a geometry object with properties to be mainly used later, for any interaction. So the renderer is going to render 3D geometry primitives like points, line, triangle, with lighting condition, camera, into 2D image that can be displayed in the render window. And the last interact classes is provide window interaction by using mouse, keyboard. So we can use this class to interact all the actors in the render window, like zoom in, rotation, pan, and so on. So so here shows one VTK pipeline program example, that is to load the robot joint, basically joint 0, and as we can see, the first step is use STL reader to load the STL model, then do the polydata mapper, then create the actor to represent this this joint model, and then do the render in this render window, and then create the render window interactor so we can manipulate this this model in the VTK environment. So here we show VTK pipeline example. We call study vtk.py. It's a Python program, and as you can see, you need to import the VTK module first, and then you create the VTK reader, and then you specify the name to be file name to be loaded, which is FunLike robot, FunLike 16IB robot, the joint 0. The file is saved under the folder this one, and then you create the mapper, which is polydata mapper, and then you need to connect the mapper with the reader. So basically you get the raw data input, make it as a raw data output, make it as input to the mapper. Then you create the actor, which will be will represent the robot joint 0 later, and then set the mapper as the previous map that you created to the actor. Then you created the renderer and created the render window, assign the render to the render window, and the last you created the render window interactor and assign the render window into this render window interactor. Then add the actor, the VTK actor into this renderer. So then we enable initiate the render window interactor and call the render window render function, and then start the render window interactor. That's all the code you need. And let's run it. So here is the VTK environment showing the loaded joint 0 of the robot. It's very easy if we want to load another one, for example 5B. So this will be the different joint to be loaded. So the second one is wxPython. That is major tool we're going to use to build this software GUI. So we're going to have one mainframe and two panel. So left panel is for VTK robot model display, and the right panel is for operation console, and the bottom will be the status bar. So here is a brief code how we create this. First, we create the mainframe class. In the initial member, we define the dimension of the frame. Then we use wxPython frame object create this window. Then we set the close event. We bound the close event with unclose event handler. So whenever you click the window close or exit, we will close the window and then destroy the object. Then we load the window into the center of the screen. We split the window into two and set the minimal panel size. Then we created the VTK panel, use VTK panel class, create the dash panel object with the dash panel class. Then we create the VTK panel and the dash panel and put them into this this frame. VTK panel in the left and the dash panel on the right, with the initial dash panel width as 440. Then we create the status bar and display the initial text as status. The last step is load the model, that is basically indirectly call the VTK panel render this member, that is to load the robot models into the VTK environment. So here is our robot simulator program, robot simulator.python, and we defined many class. The mainframe class is used to create the main window with all the panel, and in which we will have to create the dash panel and the VTK panel, which are different classes. So here's the code we just reviewed. Under the class mainframe, we created the window, and we also load the model, and we also have the onClose event handler and onReset event handler. And if we run this program, oh, I'm sorry, this one. So here is robot simulator we developed, and so this is dash panel, which has 440 the width, and the minimal you can shrink to is 300 as we defined in the program. And this will be the VTK panel, and the bottom is status bar. So to test the OPC UA package, we need to download the OPC UA client, free client, that is called wxPython. The latest version is 1.6.1 from the Unified Automation website. It's a very convenient tool to test OPC communication. And then we can try the mini OPC UA server. Basically, we set up this server, and then we use this OPC UA expert client to test the connection. Same thing, we can let this OPC UA mini server running, and then we try the mini client to test. So basically, by doing this, we can verify that both OPC UA client and the server function in the OPC UA package works. So first, please download the OPC UA client, UA expert, from unitedautomation.com website. The latest version is 1.6.1. You may need to register to this website and log in order to download this installer for Windows. So after you download it and install it, you can run UA expert. So the software GUI will look like this. The left side is basically showing which OPC UA server you are going to connect it to by providing the server endpoint. And once it's connected, the address space will display all the OPC UA nodes and variables and object in this address space. And you can drag and drop anything you want to observe into this data access view, and then locate the value change, and here we'll display the attribute of each object. So now let's run a simplified OPC UA server which provided by the free OPC UA package. So it's a simple server application. As you can see that the program is pretty simple. You import the OPC UA package, define it as server, and then you define a OPC UA server object, set up the security policy as no security, otherwise you may get some warning. Then you set up the endpoint for the server to be localhost. The port number, I try to use 4048, but somehow it was occupied in my PC, so I changed it to 4050. Then it's better to set up some username namespace, and then you create the like a root object nodes. This is where we should put our nodes basically. Then in the address space, we start to populate the objects. The first root object will be the robot F16i. Under this, we're going to have the six joint variables, and we make those as writable. And after that, we start the server, and then we do a kind of like a forever loop. Every 2 seconds, we update the joint J1 to J6 position, use a random function. So you will see the J1 until J6, their value will be dynamically changed within this specified range. So it's a very simple and easy to understand program. So let's start the server. Okay, so the OPC UA server is running and listening on the localhost port 4850. Now if we start the UA expert, which is a free OPC UA client, on the server, you just see add a server. I just see my local, doesn't matter, it's a name. Then you specify the local the OPC UA server and the port URL, which is 4850. We have no security policy anything, so select as none, and then say OK. Okay, now we connect it to the server, and as you can see, the under the objects we have the root object, which is robot F16i, and under that we have 6 basically joint variables, and we can drag and drop each joint on the here. So you see each joint value dynamically changing every 2 seconds. So this there's some setting is not correct, so we got some error message, but that's not critical for now. I think the point we want to have is the server, OPC server is running, and you have client connect to it, and you can consume the data from the server. Also, we can say that's another OPC UA client. It's a simple client. We can run and test by connecting to the server we set up before. So right now this server is still listening at localhost at port 4850. As we can see before, the 6 joint data dynamically changing. Now if we start this client and try to link to this server, we have to change the OPC UA endpoint. We connected to it. So here's the code. You import the OPC UA, you define the client object, then you give the endpoint of the OPC UA server, URL, then you call the client connect. If this is success, the OPC UE client should connect it to the server successfully. Then you pull the root of the server load, and we just print it out. Then we get it all the joint, and then we browse the the root and search some specific name, object, server status, state, and then we make a kind of like a forever loop unless you hit the keyboard. So we trying to get the specifically the joint variable that we want to access, which is on the root objects robot and then joint. So you have to remember this this tree address, which is shown in here. So you say object robot roots and then variables. So you got J1 to J6, and then you print their value. J1 get a value, J2 get a value, and then you sleep 1 second and then loop again. Okay, so it's a simple program. Let's run it. So as you can see that the client is connected to this server, the same server which UA expert connected to. So the UA expert client and our simple client are both connected to the same server, and we should see the data updated the same from J1 to J6. So this 6 value and those value are same. Alright, so this basically verified that the OPC UA package we installed works fine, and in the future we are going to use that in our robot simulator document. So the last one is multi-threading. By adding the threading module to the project, we can just use it. It's straightforward. Then we can use message pops up mechanism to send a message between different threads. So here shows an example. If we click cycle start to run the robot program, a robot cycle thread will be triggered, and if we click start the OPC UE server in the on OPC UE server event handler, the OPC UE server thread will be start. So in the robot simulator application, we have totally we can dynamically create 3 threads. One thread is for the program cycle start to run the robot program. Another one is for the OPC UE client to connect it to the server, or we run this robot simulator as an OPC UE server, so we open a server thread. And all that will be triggered when we click the operation panel button, as we see here. So for example, if you click cycle start, you see the program running a robot is moving per the program, but you still can do the very convenient operation on the panel. Cycle stop, cycle start. Okay, so that is because it is the moment when we click cycle start, we create the program cycle thread, and the main thread is still running. Same for the connect OPC UI server client thread, or start the server with XML mode thread. So once we click cycle start, basically we will, in the code, in the dash panel class, it will create this program cycle thread, and in this thread class, you need in initial member, you need to just initial the thread and then call the start. So this is your import from threading module, and then all the code will be put into the run. So here basically all the coding regarding the this thread will be put over here. For OPC UI thread, so this is OPC UI client connected to the server, it's same, and another OPC UI server thread, you can see pretty much same. This is the end of this tutorial video. Please check out above YouTube video link to see the full video of the robot simulator.